going to talk a little bit about programming, but first I want to show you, because part of this class, and I teach it in a free-form way, I've been teaching it 15 years, and we'll go back and do a little bit of review at the end of the semester, and we'll look all the textbooks, PowerPoint presentations, and we'll just be like, we totally know all that stuff. But one of the things we also learn in this class is e-commerce, and so e-commerce is electronic commerce. And before we talk about programming, I just want to take a moment to talk about e-commerce and social media and making money in today's workplace. You could still getting a degree is absolutely a great pathway. It's tried, tested, true, proven, right? A bachelor's, a master's, a doctorate, it's going to open doors to good salaries. And so you are on the right path by going to school. And it's also really good to be savvy to how the world works today. You got to stay current, and you also have to have a little bit of social capital or social clout. So if one job doesn't work out, you're in a position where you could find another job easily. So one of the things you have to do is you have to have a social media presence, right? So whatever you're into, you want to create a social media presence that is a reflection professionally of what you're doing. And so for me, I do a lot of Go programming and web stuff. And so I have a Twitter account that reflects things about Go programming and web. And just recently, and 2,300 followers, pretty good. But every day I try to tweet something, just to kind of keep it going, right? And gain a few more users. And so that's, I think, one of the first pieces of information that I would give to you. Think about social media as a tool to help you with your career. Okay, so take that piece. You got that one? And then the other thing is social media is always going to be with you. It's like what happens in Vegas no longer stays in Vegas, right? It gets posted on Facebook and Twitter. And so that's like true in Vegas, that's true at a frat party, and we already talked about this. So you have to be really careful what you post on social media. Because if you post the wrong thing, then that could compromise your career prospects. And people could take a look at, well, that person looks a little bit too wild on the weekend, right? I want people who are a little bit more grounded or a little bit have more of these values as opposed to those values. So you need to really think about the image that you create, that you put out there. And so it's a trade-off, social media stuff. So the other thing is that could also help you generate traffic and generate revenue. And so whatever you're into, if you have your own business, you're a realtor, you're a consultant of some sort, you're a lawyer, you're a financial consultant, investment advisor for like Merrill Lynch or something like that. People like to see that you're somebody in a community that is a community thought leader, and you have a lot of followers and you post information about it and you stay current. Because if you're looking for somebody to manage your money and you go and you look at them on Twitter and one person has tweets about drinking, right, and being at the lake, and another person's like, really interesting article from the Wall Street Journal about, stock performance in portfolios. You're like, sweet, look at that dude. Look at that person, right? That person's doing really well. So that's the first thing that I just share with you. All right, so the second thing is we're going to talk about programming today. So I'm going to give you all access to my programming classes on Udemy. And so access on those programming classes on Udemy, you could get into both my HTML, CSS class and also learn how to code with the Go programming language. You could get in for free using the access code Apollo. Or if you happen to come from a situation where your parents own oil wells in the Middle East or something, right? And you have a lot of money, you could get a discount right here and buy me a beer. So that would be a little bit of a discount. Or if you're going to post it on social media, hey, check out Todd's course. Use these links down here. So I'll post these links up in Blackboard so that you all have access to that and you could get into the courses. So, announcements. All right, so those links are posted, and if you're online watching this video, sweet. I totally commend you for forwarding your own education and watching this. And you can also gain access to the course for free, or if you have the financial means, buy me a beer. And if you can share those on your social media site, that would be great. So notice right there how that's working, right? Like I'm in class, I'm teaching you all something. At the same time I'm recording this, I'll put it on YouTube. Students who weren't in the class, hey, what happened in class? I wasn't able to be there. Oh, go watch the video. And all kinds of other people in the world will be able to watch this video, right? And in doing that, I've also promoted my Twitter account. Maybe they'll follow me on Twitter. Maybe you'll follow me on Twitter. And I've promoted these courses, which I've created in my own time, separate from the university. Faculty used to write textbooks, and then they'd sell those through publishers and make a little extra money. Long tradition in academia. Now, a new way that we could do that as professors is creating video lectures. So I've promoted the video lectures that I have out there. And that, in turn, results in revenue. And so I think we've looked at this before. But some of the revenue that comes back from that, and I'm sharing this with you to open your eyes, to be diversified, get your bachelor's degree, get your master's degree, and go to work for somebody, but at the same time, diversify your portfolio, right? Like get everything to work together. You know, and so if things don't work out with your employer, you decide to transition to something else, you have other income, other revenue streams coming in. So by making videos, 55,000 people have watched my videos in the last 28 days. We looked at this before. And that's generated $82, or about 0.2% of a penny for each view. Which if you get enough views, that's significant money. Like Justin Bieber, like 2 billion whatever views he has, he's made millions of dollars off of people watching his YouTube videos. That's pretty cool. So that's one way that you could also generate money. As a student, how would you do that? Like there's a guy on YouTube that I subscribe to. I like his channel. No, I can't remember what it is. YouTube. Do I subscribe to it? Because I get his email, so it probably shows me who I'm subscribed to. I already have that up. Let me find him. All right, so I subscribe to this guy because he does some interesting little computer videos. And when I go and I look about, did I start recording again? 7:24, 7:25 I did. When I look at about, he's had 1.268 million views. And he's got 11,000, almost 12,000 subscribers. And he's a student in England studying computer science. And he learns a topic, and then he takes that topic that he learned that week, and he makes a video on Friday. Hey everybody, I'm going to teach you about RAM. So he's reinforcing his own learning by taking what he learned and teaching it to other people. And then he teaches it to other people, and he gets views on YouTube, and he makes 0.0015 cents a view. So he's made $2,000. Is that right? That would be a penny, so that's not that much money. I don't know if I did the math right on that. I guess I did. Is it 0.015 cents? In which case it's 19,000. I think it's that. That can't be 15 cents a view. That's not right.
That's if,
it's 0.015. Yeah. So still, he made a little bit of money. And he has all those followers. And he has a little bit of presence. And then when he goes and applies for a job, it's like, hey, look who I am. Look at what I've done. Is any of that helpful to people? Yeah. All right. Cool.
What's the name of the channel?
Of this channel that we just looked at?
Yeah.
Mine or his? His is, I don't know if that's an I or an L, so that's bad choice on his part. Maybe just 0612 TV. Now on Patreon, give me money, please. You could be a patron of somebody if you like their work and send them money. The old patronage system, kind of cool. All right. So we're going to talk about coding today. Does anybody have any questions about all of that? No. So let's talk about coding. So we'll do a little bit of an overview, and then we'll do some hands-on stuff with coding. So when we create a program, just some of the key words, we write programs with algorithms. How many people have heard the word algorithm before? Anybody know how to define it?
It's like a code of like zeros and ones or something
Code of zeros and ones. Steps is a good one.
Something like code is a way of doing something.
A way of doing something. A process. So in math they talk about algorithms too. And so mathematical algorithm. An algorithm's a solution to a problem. You could also think about it that way. So what's the algorithm for that problem, solution to a problem? So we write algorithms, just solutions to problems. And in programming, algorithms have to be really specific. So you have to detail every possible situation and case and account for it. So if somebody was to program me to pick up my keys over on this table, right? Anybody want to try to, like, I'm the computer, you're the programmer, you give me instructions about what to do, and they have to be totally specific. So just as a class, program me to get me to move over to those keys and pick them up. Give me instructions, step-by-step instructions.
You walk to your right, like, or to your left, 3 steps, 5 steps.
I'm walking to my left 4 or 5 steps. Huh?
Then go 1 step forward.
1 step forward.
Go right 1 step.
Computer right there that you can't see. Now do what?
Actually, I don't see what is the key. So.
Right there.
Right there. Okay. Then you find a key.
I found a key.
You will find a key.
I will find a key.
Yep.
I don't know what find means. Does not process. Give me actions and movements.
What is the valve?
Huh?
We'll find the keys.
Look down.
Yeah.
Look to the right. So you kind of get the idea, right? But you got to be really explicit. And you know, he told me to walk to my left, but he didn't tell me to turn, so I walked sideways to my left. And that's programming. So it's a very literal occupation. There's a joke that a programmer died. Nobody saw him for a week, so they went to his apartment. They found him dead in the shower, and the water was still running, and he's holding a bottle of shampoo that said, lather, hair, rinse, repeat. Never told him to stop, so he got caught in an infinite loop of programming. Okay. So when we first wrote programs, it was like 1 page of code. And I remember in like 1982, that's when I started programming. And then I quickly stopped in 1983. And I started again in 2001. And then I stopped in 2005. And I started again in 2013. Kind of weird. But I had a programming class in junior high in 1982 or 83. And we learned BASIC. And in BASIC, we'd do like just a little loop where it'd count out and print out numbers. And all that code was on 1 page. And each instruction was on 1 line. And you'd have different instructions which would say, go to this instruction, go to that line, go to this line. And that was really hard to follow the logic because there's no spaghetti code. Because the code was just all clumped together like a bowl of spaghetti. And just like it'd be hard to follow 1 strand of spaghetti in a bowl of spaghetti, it was hard to follow 1 strand of logic in this big bowl full of code, this 1 page full of code. So they called that spaghetti code. And then they started to break the program, the code, up into procedures. So this is known as procedural programming or structured programming, breaking code up into procedures or structures, making it more structured. And so you'd have different functions. You could call different functions, run this procedure, run that procedure, run this function, that function. And so that's more structured. And you can kind of see, okay, well, that little chunk of code, that one little algorithm there, that's the one for calculating the square root. And then we could just call that, and it'll give us the square root on any number. So, you know, let me just give you an example of this. It's like way too cold in here originally, and now it's like way too hot. You guys all see this? That text is big enough for you? So one of the original programs I remember writing back in the 80s in BASIC, I'm going to write it in the Go programming language, which is a programming language created by Google. It's the best programming language to learn today if you're wanting to get started with programming language. And the links I gave you is a course to teach you how to use this language. But if I wanted to do that, I could do a for loop. And a for loop is going to take some sort of a declaration, like I'm going to declare I is equal to 0. And then it's going to have some sort of a condition. So yi is less than or equal to 100,000. We're going to run this, and then it'll loop every time. And then for each loop, right? For each loop, it's going to keep track of what loop it's in and do something. And I want it to print out the value of I. Print out the value of I. And so when I run this, 100,000, how long will it take the computer to count to 100,000? Done. And it printed out all of the numbers between 0 and 100,000. Like, that's all sequential, every single number. And so when you see that, you start to get the sense of the power of computers. Because if I needed to print out every possible combination of the lottery numbers and then buy each of those tickets and automate it, the computer could do that in not too long. I need the money to buy every ticket and some system to purchase them, but computer could generate every possible combination of numbers. So that would be a loop. But you know, I could also put this into a function, so I could break my code up. And so I could create a function, and I could call this function func and just create some new function. I'd call it, you know, I don't know, counter, and then put in here that. And then I could call counter up here, and I could run counter. Because main is where your program runs. So I'm just going to do it to 100 this time. So main is the entry point in this programming language. And that's where the program starts. It sees here, I need to run the counter function. So it goes down here to the counter function, runs this code, and then comes back up here, and it could run the next line. Okay, and when you leave main, you're finished with your program. So what did I do? I forgot to close that. See, you have to be very precise in programming. So it ran, entered main, that's where your program starts, called the counter function, ran this code. Okay, I'm done with counter, went down sequentially to the next thing, right? And then printed out, I'm done, exiting program now. Pretty cool. How many people that's interesting to you? Yeah, isn't that interesting? And so what can you do with that? You could do things like this. As you learn the language and get the basics of the language, I'm just going to do some class examples here in class. And the first one will be just like a web server. And I'll create a new main function. And it becomes a language like any language. So you first start learning to speak a foreign language. You're like, yo, mi, lamo, tad. And somebody says, no, 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 yo me amo tad. Or just me amo tad. Oh, me amo tad. You don't have to say yo? No, you don't have to say yo. It's implied. Oh, okay, me amo tad. You know, and you start to learn how do you do things and how do the verbs work and the nouns work. And then after a while, you're down in Mexico and you're having conversations with people. Sweet. It's the same way with programming. At first, you're like, what? How do I say that? How do I do that? But then after a while, you know this new language, you're having conversations. Or you're writing things just like you'd write a letter or an email. You're writing a little program. So I create a new program here. This one's main. Package main is always the main. You can break your code up into packages. And so package main is the main package. And then main is the main place where we enter, right? And I could do HTTP, listen and serve. And I say I want to listen on a certain TCP port, and I'm going to do a default serve mux. And you learn all this stuff. And you can learn this with me in the class in the spring, CIT 94. Though over Christmas break, I'd want you to watch my online class and become familiar with the syntax of the language. Go through the first half of that, so when you came into class, you weren't like, how does this language work? But you're like, oh yeah, I totally was working with that stuff over Christmas. So now I'm going to do HTTP handle func. And I could say when something comes in just at the root of my website, I want to run a function called foo. So now I'm going to create a func foo, and you have to have a certain signature to this function. And part of that signature is response writer. And then the other part is a pointer to an HTTP request. And you'd learn all about that if you took my online class. And the reason you need this signature here is because the way the web works is you have clients make requests to servers, and then servers write a response. And so I'm going to run my web server listening on a certain port, and handle func will anything that comes in this route will handle, that request, and you'll see that in a second. And the request comes in, and then we write a response. So I'm going to write a response. So I'm going to do IO write string, and it takes a writer, which is my response writer, and then I could say something like, you are at foo. And I could duplicate this, and I could say, you are at bar. And I could duplicate this, and I could say, run this function if somebody goes to bar. I need to change the name of it down here. So now when I fire this up, you are at foo. You are at bar. Whoa. I'm programming the web. That wasn't that hard. And you could have it start to serve up web pages instead if you want it to. Like, that's pretty cool. And then you could start creating your own websites and start working for people doing websites. How much do you charge? $65 an hour. So,
Just making a website?
sure. If you learn all this stuff, like you go through our web program, we will prepare you to be ready to enter something like Hack Reactor. And if you enter Hack Reactor, they place 98% of their graduates in jobs, and the average graduate salary is $104,000. So in like 2 years, you could be making $100 grand programming the web. Take the classes here, apply to Hack Reactor, spend 6 months up there. It'll cost you, I think, $17,000. But then you graduate and you make $100. That's a good code pathway. If you need to get earning. And then you just keep working your education in the evenings, right, to get your bachelor's, your master's. But you're up in the Bay Area, you're making great money, you're meeting really cool people. Yeah.
I don't know if this is dumb or not, but is this coding or?
Yeah, this is coding.
So it could be called programming or coding.
Yeah, programming or coding. Which do you like more, programming or coding?
Coding.
So that's breaking things up into procedures, making it more structured. And then there's been other iterations on top of this, like turning things into objects and thinking about things in terms of like we interact with objects in the real world. And so that's more like known as object-oriented programming. And we create objects, like we create a person, and we sort of define the structure of a person. And then we could, person knows certain things and does things. Objects know things and do things. And so the things it knows is data it holds about a certain object. And the things it does is like things that it'll do. So I can give you an illustration of that too. And I'll just create a new example here. I'll just copy this folder. And I'll change the name of it to, and this is actually called, composition, because it's a little bit different than OOP, but a lot of the same similar principles. So I'm going to get rid of all the web stuff here. And I could create new types. That's weird. So I'm going to create a type person, and it's a struct, which is a data structure. And now I'm just defining what this AKA object's going to be like. And a person has a first name, and a person has a last name, and I don't know, first name, last name, and an age. And these are different data types. Age is going to be an int. And so then I could create a person, and I use a composite literal to do that. So person1 colon equal is going to be a person, and then I populate the fields with data here. So the first name would be Miss, and the last name would be Moneypenny, and she's like probably 24, right? And then I could print line. I could print out, show me that person, and so there's Miss Moneypenny. So I've stored data about somebody. But somebody could do something too. So I could create a new function and use a receiver to attach this function to the type. So type person knows things, right? Knows things. I'm just defining the structure to be reused over and over and over. So if I'm creating an application for a business, I might do employee. And this is what we want to store, the data we want to store about each employee. And these are the things we want each employee to be able to do in the program, right? So we'd create this kind of stuff. And then we'd use that data to create instances of like, oh, here's another employee and another one and another one. So we're defining kind of like a template. This is what we'll store for each employee, and then we're using it. So for the person speak, I could say funct print line. And I could say p1.fname, p.fname, p.lname says, good morning, James. It's so good to see you. Miss Moneypenny loves James. And so now I could call that p1 speak. I could call that function attached to that type, of which p1 is is a value of that type. Miss Moneypenny says, "Good morning, James. It's so good to see you." Now the cool thing about that is I could create additional types. So I could also move this all into one line, just to sort of get my code a little bit more compact, and I could duplicate it. And I could say this is P2, and who's the boss in James Bond novels? It's also a woman, right? And she's Q? No, Q's the tech person. All right, M's real name. M, Olivia Mansfield. All right, so her name is M, not Q. And where did our code go? Back here. So her name is just, I guess we'll do Olivia Mansfield. And she's like really old, my age. And so then we could do P2 speak, right, and run that, and they both say it. They're both saying the same thing. But we could start to customize that if we want, you know. We could say greeting string. And so down here we could put in the greeting. And then we could change this to says, so I'm going to see if this works. See what printf, what the signature is on that. There's a format string and an interface. Okay, I see what I have to do. There we go. So I do comma, put that there, and then I also need p.greeting, and I need to put in, go look at my formatting verbs, so I go to the documentation and look at the package. And %v is the default format, and when it's %v, the default format is going to be S for string. So I could just use %v's, but maybe I want to be precise. Let's run that and see if I made any mistakes. Miss Moneypenny says, "Good morning, James. It's so good to see you." Well, there's my first mistake. Olivia Man 0202. That's my editor messing up. So let me put in at the end. I want a new line. Let's run it again. Doot 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 doot. I thought it was that way. That doesn't look right. New line. Maybe my double things are messing up. I gotta pause this and figure it out. It's printing out the new line because I'm inside of a string literal. So I need to take that outside the string literal. And to put it outside the string literal, I guess I just have to do this. Take it out of a string literal. That's the easiest solution. Okay. So it becomes a little bit interesting. So there we go. Now they're both on both lines. Miss Moneypenny says, "Good morning, James. It's so good to see you." Olivia Mansfield said, "Bond, what the hell are you doing?" You kind of get the idea, right? That gives you a little flavor of how programming works. One of the things you saw me using were control structures. So you saw me talking about the sequential control structure right here. Programs execute in sequence. It goes into main and then it just starts going down through the code. And then here we hit an iteration, which is a loop. And so it goes around and around in a loop. And the other thing we could have done is conditional logic. And so if I, well, let's do this. We'll do I%2. And I think that gives us the remainder. So let's run that just for 20 and see what that gives us. 0, 1, 0, 1, 0, 1, right? So the remainder of, here we'll do I, comma that, and now run it. So when I was 2 and we divide by 2, this gives us the remainder, and it's called modulus. When I was 2 and we divide by 2, the remainder is 0. When I was 3 and we divide by 2, the remainder is 1. When I was 4 and we divide by 2, the remainder is 0. This is the remainder right here. So we could do some conditional logic, and we could say if I modulus 2 is equal to 0, format all that, and now it's only going to give me even numbers. Whoa, conditional logic. So now you've seen all 3 of the control structures, flow control structures. You've seen sequence, which it enters main and starts going sequentially. You've seen loops or iterations. Here we're looping, we're looping, we're looping. And you've seen conditional logic, making a decision based upon a certain condition, do this or do that. Whoa, pretty cool. So those are control structures. We also occasionally have bugs, like all the time in programs that we have to find and get it fixed. And that's a long tradition. Grace Hopper is a famous computer scientist. And back in the 40s, when they debugged computers, I guess that's her right there. Right? Here's a log from the computers. Relay number 70, moth in relay. First actual case of bug being found. So when they talk about a bug in a program, back in the day, bugs used to fly into the computers because they were warm. And they had vacuum tubes. Right? And then the bugs would short out the vacuum tubes and they'd have to go debug the computer and pull the bugs out. Huh?
That explains that.
Isn't that funny? Found a bug in the computer. So that's just been used ever since then. We have variables and types in programming. So I could create variables, like right here, get rid of all this. And I could create a variable var fname and say it's going to hold a string. So I've declared that there's a variable fname and it's going to hold a value of type string. I could declare a variable called age, that's the identifier, and it's going to hold a value of type integer, int. And then I could say fname is equal to Todd, and age is equal to 27. And format println fname age. So that's creating a variable. It's just some sort of a little identifier container to hold a value. And we have to specify what type is that value. Interestingly, we could see the address in memory where those values are stored. Whoa. So memory is nothing but a bunch of little cubby holes where we put zeros and ones. Here's the address, the 2 addresses where fname and age is stored. Those are the little cubby holes, the little storage like mailbox, whatever, where those zeros and ones for that value, Todd, and that value 27 where they're stored. Isn't that amazing? And that's useful because if I have a program and I'm storing like a big piece of data, like, I don't know, like all the employees for Chevron, and here they are in this map, right? That's going to be a lot of data. I don't want to pass that around through the program because that's all moving through the CPU. And what I could do is I could just say it's all stored right here in this one memory address, or that's where the storage starts, right? Pointing to the underlying data structure. And I just pass around that memory address, and that's fast. And it's just a short little thing I'm passing around. It's like, where's all that data I need? It's right there. So they call it a pointer. We now take a break from our regularly scheduled presentation for an announcement from our sponsors. So that's a little bit of an introduction to programming. Anybody have any questions about it? It is one of the coolest things You can study today. And the reason it's cool is because it combines engineering and art, and it's highly demanded. How does it combine engineering and art? Because you are building, you are creating, you're building something when you become a programmer, and that's art, right? Let's create something new. Whoa, all right, cool, let's do it. Build something new. You're not going to work, like just doing the same old thing. You're like inventing, you're innovating, and it's really well compensated. So if you have any predilection for it, pursue it. And when you get bad teachers, don't let them stop you, right? Because I could see at the beginning of this presentation, there's like 2 hands. And then like as I started like doing stuff, you guys were like, that's not too bad. And like more hands went up. It's like, that actually looks kind of cool. It's totally cool. The founder of Dropbox said, if you know how to code, you have a superpower. It's like having a superpower. You can do things that the vast majority of people can't do. It's like the vast majority of people are walking around, and you're like, well, I could be a little bit more productive than that. And you're like flying. Not literally, metaphorically. But you're like, okay, well, let's create a little program that goes and crawls all those websites and pulls that data down to us, and then we'll create another program to start some campaign for contacting them, and then we should be generating like 100,000 a month. Oh yeah, that sounds good. Let's do that. I like that idea. You could do it. And like any craft or any skill, it takes time. There was some paper here. I don't know where it went. I'm going to demonstrate. Oh, the paper's gone. I'm disappointed. Okay, I found some paper. I'm wadding up paper. And Ahmad, is that right? Ahmad?
No, Abdul.
Abdul, sorry. Okay, I don't want to hit you, Abdul, sir. Heads up. Roll back a little. These are my basketball skills right here. I got to be able to see that basket. You're still in the line of danger. Oh. I had good velocity, a little bit too much. It was in the right area. I hit the backboard. I'm going to try again.
A little more on.
Oh. Right? Third time. Anybody a betting person in here? I'm hustling you all. I intentionally threw those first 2 shots. None of them. But if I did that every day, after 3 years, I would be hitting a high percentage of those. And it's the same way with programming, just like it is with basketball or playing the piano or playing the guitar. Or speaking Spanish or a foreign language, when you first start out, you suck. But then you just do it a while, and pretty soon you're like, why don't you just like pipe that into the output of something else and use grep? Oh, good idea. And you totally know what that means, and you can totally do it. And you search the whole computer in a matter of seconds, and you find exactly what you're looking for out of billions and billions of results. I wish I'd studied it when I was young. No better note to end on than that. Any other questions? I study econ and business. So in the spring, CIT 94, you can learn how to build websites. We'll be doing the technical side, the server side. How do we create sessions? How do we authenticate users? How do we store user information? We're not going to be doing the pretty side, which is how do we make it look pretty on the front. We'll be doing the back end. How do we build the application on the back end? But you have access to both those courses now on Blackboard, where you could see how to code. This is the one that you need to take if you want to take 94 with me. And the HTML and CSS. I'm also offering the HTML and CSS course in the spring. So you can take them both. And then by next, end of next semester, you can have a really good working skill set with creating websites, front end and back end. You'd be well on your way. I launched a new video, how to make money online. So you could find that by going to Todd McLeod YouTube. And then when you come to my YouTube thing, go to my videos. And then you could go to that video right here. And you could take a look at it. But that talks about selling courses and things like that. But I give you all these tools because Fresno is not a vibrant economy. And you are not limited in terms of your career potential right now. You need to start right now. And just you have to start putting up really dumb stuff before you start putting up really good stuff. So get that dumb stuff out of the way. Just start making videos if that all interests you. But if you're interested in that, take a look at it. It's pretty cool. All right. Anybody have any other questions about programming?
If you know HTML, are like the skills transferable to Go, or what's that code language you said Google uses?
Yeah, so HTML and CSS are used for the front end of a website. JavaScript is used to give a website functionality on the front end. So you could program it to do things on like check the password so it doesn't have to go all the way to the server and back. And then Go, it requires to do web programming. Go, you should know some HTML and CSS because we'll talk about some HTML and CSS. And the front end interacts with the back end, so there's certain ways you build the front end. But they're all three separate things. It takes some getting to know. Any other questions? Cool.